These are the Algebra 2 notes about 8.2, which covers two-way tables and probability. So first we're going to talk about a joint frequency. A joint frequency is the entry into a two-way table. I'll show you what I mean in just a second. It makes more sense once we do one. The marginal frequencies are the sum of the rows or columns in a two-way table. Okay. So in example 1, it says, we have a survey about attending a school concert. 106 juniors and 114 seniors respond. Of those, 42 juniors and 77 seniors plan on attending. Organize these results in a two-way table. And then it wants us to find and interpret the marginal frequencies. Okay, so if you just start, leave some room because we're going to add on to this table. So if you want to just see me make real quick the outline, that's totally okay. And so what I have here is the first option is they can be juniors or they can be seniors. And I'm going to call this grade. And then the other option over here is they can, let's see, they were planning on attending a concert. And so they can plan to go to the concert or to attend and then not going. And this side is attend the concert. All right, and so when you do this, these four entries right here are called the joint frequencies. All right, and so like for example, if you have 42 juniors who plan on attending, under the juniors who plan to go, that's 42, that goes right there. And so it's telling you juniors and plan to go, that's why it's called the joint frequency. And then 77 seniors plan on attending. So plan to go and seniors are 77. Now, if you add on a total column and row right here, then that lets us use the other numbers that we have. And these numbers in these total column and rows, these are called the marginal frequencies. So when they say to organize these results in a two-way table, these main four, so if we go right here, these main four numbers right here, these are called the joint frequencies. And marginal frequencies are the totals of the rows or the columns. All right. So I know 106 juniors respond, so the total juniors is 106 that goes here. And then 114 seniors respond, and so that goes here. So the rest of this is just filling out, it's just kind of like doing a puzzle. So for example, I'm planning to go 42 plus 77 means 119 students are on the plan to go. To find this number of juniors not going, you could do 106 minus 42, and that would be 64. To find seniors not going, you could do 114 minus 77, and that's 37. And then you can add up 64 plus 37, and it tells you there are 101 juniors and seniors who are not planning to attend. So to find this bottom right column, this is the total number that respond, right? So it's, I think of it as the total. And so if you want to find this, you can either add up the 119 plus 101 and you get 220, or you can do the 106 plus 114. It's a good way just to check that your numbers are checking out. And so that's our two-way table. Okay, so example 2 wants us to use these survey results to make a two-way table that shows the joint and marginal relative frequencies. So this is the key right here. When they say the joint frequencies, they mean these four numbers. When they say the joint relative frequency, they're going to mean these four numbers, but they're going to be written as a decimal. I'll show you how. Marginal frequency was these four in green. Marginal relative will also be in these four locations, but they'll be as decimals. And then we're going to interpret. Okay, so I'm going to leave that table in view, and I'm essentially going to go ahead and just create the same table. I'm going to try to give it enough room to write in. And so just kind of when you're making this, I'm gonna make the same table just a little bit larger so I can write in it. All right. And then I have my plan to go and plan to not go. I'm just gonna put attending. This box isn't actually there. And then I'm gonna have my juniors. I'm gonna have my seniors. I have my total. This is our grade level. And I guess that box that I said shouldn't be there really technically should be a total row. Okay, so finding this is not terribly difficult once you know what to do. We're going to use our calculator to do a lot of it. So you take this number that is in the juniors planning to go, that's 42, and you divide it by your total responses, which was 220. So 42 divided by 220 is going to be 0.19. And I'm just going to go to 2 decimal places. So then seniors that were planning to go was 77. So I take 77, I divide it by 220. And I just do that in a calculator. And I get 0.35. And so the nose was 64 divided by 220. And I get 0.29. And then 37 divided by 220. I get 0.17 when I round it, it's 168. So then you can go ahead and you have 2 options to find. Those are the 4 joint relative frequencies. So relative, think of the R in relative as ratio. So I made my ratio. So those 4 numbers are my joint relative. To find the marginal relatives, you have 2 options. You can take this 106 divided by 220. And so if I do that, I get 0.48. And the other way I could have found that is just by taking 0.19 plus 0.29 and I get 0.48. So that's also an option. It's just adding up the rows and columns and that will work. And or just taking the number that was in that box and dividing by 220 because that was the total number of responses. So either way, it's just a personal preference on what you want to do. Now, if they don't add up to 1, that's probably just due to rounding, because rounding can make you just be slightly off, and if you're only rounding to 2 decimal places. But so usually they'll add up to 1. They may just be slightly off if like they rounded up and they just barely get enough that they end up like 1.01. That happens sometimes. All right, now we need to interpret. So we want to interpret one of each. So for example, if I want to interpret this 0.19, it means that 19% of the students surveyed, so of all the students surveyed, are juniors who plan to attend. So it means out of all the students who answered the survey, 19% are juniors who plan to attend. So that's an example of a joint relative frequency. Let's try a marginal relative frequency. For example, let's try this 0.52. That's a marginal relative frequency. So it means that 52% of the students surveyed, not the whole student body, just of the 220 students who were surveyed, 52% of the students surveyed, 52% of the students surveyed are seniors. And that would be that marginal relative frequency. So a joint relative frequency and a marginal relative frequency are just the ratios of a joint frequency or of a marginal frequency with the total number of observations or responses. All right. So then if we go down and look at example 3, a conditional relative frequency is a ratio of a joint relative frequency to a marginal relative frequency. And this will also make more sense once we actually do one. All right, example 3 says, use these survey results in this example, make a two-way table that shows the conditional relative frequencies first based on the row totals and then based on the column totals, and interpret one of the conditional relative frequencies in each table. Okay, so just to set this up real quick, I'm first going to do the row totals, and I'll show you what I mean. And so we are going to have our attending, and remember that was yes, attending, and no. And then we had our juniors, and we had our seniors. All right, and I'm leaving space to write. And I do not actually need any total columns on this. All right, and so if we take the number that is in the yes juniors, that number was 0.19. And then if we go ahead and we take the row total, the total in the row was 0.54. So I'm going to take the 0.19 and I'm going to divide by the row total, which was 0.54. All right, that got me 0.35. So then on seniors, take the number of seniors was 0.35 divided by the row total, which is divided by 0.54. Sorry, I should have made this bigger. All right. Which I did in my calculator is 0.65. So to find the no's, you take the number in the no juniors, which is 0.29, divided by the total of that row, which is 0.46. So 0.29 divided by 0.46, which is 0.63. And then go ahead and you're going to do 0.17 divided by the row total, which was 0.46. And I got 0.37. Okay, so trying to interpret one of these, let's just interpret 0.65 just for example. So keep in mind, this is out of the rows. This row is yeses. So it means that not 65% of total students, it means 65% of the students who said yes, they are attending. So of the students who are attending, 65% of those students who are attending are seniors. So of the yes attending, 65% are seniors. Versus like the 0.37 below it would mean 37% of the people not attending are seniors. So it's out of the row. So now if we make a column, I'm going to do a little better on this one and leave more room to write. All right. So if I go here and I have my yes attending and my no attending, and if I have my juniors and my seniors, the only difference on the column totals, which is what it was here, is I take the number in that box, so in that joint frequency, the 0.19, but I divide by the column total, which is 0.48. And then so the number in here was 0.29 divided by this column total is 0.48. The number in here was 0.35. This column total was 0.52. This number was 0.17. The column total was 0.52. I'm going to pause. All right, so if I try this one again, this is out of the column. So this means 67%, not of the yes attending, 7% of the seniors who answered this survey. So out of the seniors, because that's the column, are attending. So 67% of the seniors are attending this concert.